Hello everyone. Today we're going to be solving another math problem. This one is from Mexico, from a national olympiad from 2019. So this was a recent one. It was the first problem of the first day, so it's problem 1 from 2019. So yeah, let's get started. If you like this type of content, consider subscribing. I also do some gaming without commentary, and yeah, let's do this. So first of all, we see that this asks us to find every positive integers that are smaller than 219, and that can be expressed as n to the power of d of n, where d of n is the amount of positive integers that divide n. So basically d of n is the amount of positive divisors that n has. So for this, we have a very nice formula to find d of n. d of n. This is equal to, well, first let's decompose n. Okay, so n, for any number we can factorize it as a prime number to a power to any power, like we don't know which power it is, so we're gonna call it p1 to the power of a1. Here it is. So the same thing goes, this is also multiplied by another prime number that has maybe a different power, so we're going to call it p2 to the power of a2, and we can go on until we have pk, or multiplied by pk, which is the largest prime number, to the power of a k, which means that this the decomposition of n, no? So we have this right here. We're gonna take this and use all of the powers. We're going to be focused on the power a1, a2, a3, and so on to pk. So basically, to get the divisors of n, we just multiply a1 plus 1, and that is multiplied by, and a1 plus 1 is multiplied by a2 plus 2 plus 1, sorry, and that is multiplied by a3 plus 1, and so on until we have a number k and plus 1. So this is a very nice formula. It may help on the problem, but yeah, it's easy to demonstrate if you want to do that by yourself. So yes, now we go on. What I first thought of was getting the square root of 2019. Why? I thought of this because the divide n has at least 2 divisors if it's a prime number. We don't consider 1, but basically for any n, you have at least a power of 2. So we get the square root of 2019, which is about it's about 44. We're gonna count it as 44 with some decimals, but yeah, we're gonna say it's 44. And this means that we have every prime number smaller than 44 will be considered for the problem. Now we get the cube root of 2019. Why? Because prime numbers only have 2 divisors, but other numbers have at least 3 divisors, which means with the cube root of 2019 it is about 12. It's 12 point something, but we're gonna say it's so. So yeah, we have to try every number smaller than 12 and every prime number smaller than 44. I'll write those and I'll see you later. So yeah, I wrote the every number smaller than 12. We're not gonna consider the prime numbers because, well, we're gonna write those later on. So with 1, we know that it only has 1 divisor, so 1 to the power of 1 is 1. And with 2, 2 is a prime number, so it's 2 squared, which is 4. Now with 3, 3 is also a prime number, so we'll just write a 9. And 4 is, well, 2 squared, so it has 3 divisors, which means that it's 4 to the power of 3, and that is 64. Now 5 is also a prime number, so it's 25 the answer. And with 6, 6 is 2 times 3, so it's the combination, well, the product of 2 prime numbers. So we know that it has 4 divisors, and that is 6 to the power of 4. It's a large number. It's 1296. And with 7, 7 is also a prime number, so it's 7 squared, 49. 8 is actually 2 elevated to the third power, so it has 4 divisors, which means it's 8 to the power of 4, which is equal to 2 to the power of 12. But 2 to the power of 12 is actually greater than 2019, so we're not gonna count that, we're just gonna cross it off. And we know that a number that has 4 divisors or more won't be accounted because the base will be more than 8 and the power will be at least 4, so it will be greater than 2019. 9 is just 3 squared, so it has 3 divisors, so it's 9 to the power of 3, which is 729. There it is. And with 10, 10 is 2 times 5, so it also has 4 divisors, so it won't count either. 11 is a prime number also, so we only have to put 11 squared, which is 121. And 12 is 2 squared multiplied by 3, so that means that 12 has at least 4 divisors. It has actually 6 divisors, so we're not, 12 is actually not gonna count either. So we have every single number that is smaller than 12 that counts to this. So the next thing we're gonna do is square every single prime number smaller than 44. Why? Because all of them will count, because 44 is the square root of 2019 and every prime number has only 2 divisors, which means that we will write every single one of the prime numbers squared, but I'll do that and see you later too. So I finished writing these numbers. They are in here. There are all the prime numbers greater than 12 and smaller than 44, unless I missed the number in which case I'm sorry. Well, here are all of them, and I didn't write their squared number, but they will work. They will be smaller than 2019. So basically the answer is all these numbers, this set of numbers, and these two numbers, and all the set of the prime numbers that are smaller than 3, or the prime number smaller than 44. So here are all the numbers that accomplish this, or that meet the requirements. So we finished this problem. I hope you enjoyed this, and if you have a doubt of where this problem came from, I will leave a link in the description. It will show where I got this problem and the exam, and I also leave a link in the description where I get some problems and where I practice math usually. They're in Spanish, but you can check it out if you want. So yeah, I hope you enjoyed this video, and I hope that I didn't mess up somewhere in this. So yeah, bye.